Hello all and welcome to the next project. In this project, we are going to build a data analysis and ML pipeline. We are going to take advantage of BigQuery and the TensorFlow to build a ML-driven loan default prediction model. What we are going to do is that we are going to have a model can predict whether a customer is a good case for giving the loan to her or not. And later, in a BigQuery as a data warehouse, we can run some SQL queries to understand better these data. So it means the goal of this project is to automate the decision making in the bank to eliminate all the underwriting inconsistency for assigning a loan to a customer. At this moment, the bank has some issues for manual underwriting. It takes a lot of time to just make a decision about the loan because there are a bunch of documents and they have to analyze all those documents. Also, there is not any consistency in the document analysis. They are being done with human, and everybody has its own idea or preference for assigning a loan to a customer. Also, there are some data in the bank, and there are a bunch of historical data, and because of those data, they are stored somewhere. That human is giving the loan to the customer might not use those data. So the bank asks us to build ML-driven system to automate all this process. In just milliseconds, the automation ML platform can just let the stakeholder know this customer is going to have loan or not. And also, this is 100% standardized based on algorithmic evaluation. So the goal is not just eliminating human oversight, not definitely, because at the end of the day, the human is going to use that model. But our goal is to systematically triage volume deploying manual review, only where it adds some values for the bank. So it means we have some data. For example, we might have the credit score, we might have the income of the customer, we might have debt into income ratio, the employment history, the past payment behavior, and all the information. And after that, we can just create the applicant profile, and the model can use this profile to make a decision. So what model is going to do is that it's going to make the spectrum based on a probability, and it's going to say, okay, this customer is in the low risk, and we can assign the loan to him, or this customer is high risk, and it's better to not align that loan to them. So it is just a spectrum, but as I said, this is the human, this is the bank is going to make a decision based on this probability. So it means the model is going to just give the probability a score. And it's not just say, okay, give this loan to that customer or vice versa. No, the model just gives the probability a score to the managers, to the stakeholder, and they make a decision about that loan. For example, they can say, okay, if a customer is categorized as a low risk, we can go for auto approve because this is a low risk. If this is the medium risk, okay, we can manually review. And this is a high risk, again, auto rejected because there is no room for manual analysis. So it means after running this project, even the company can build another model on top of this model to build one of these scenarios. If this is high risk, go with auto reject. If this is low risk, go with auto approve. And if this is medium, just hint and notify the bank advisor to manually review those documents. So we are ready to build this project from the scratch, and we are going to start from reading the ERD or the entity relationship diagram to make better understanding about the data. After that, we can jump to the BigQuery to create our warehouse. Then we can build the ML model with help of the TensorFlow for the deep learning. And after that, we can come back to the BigQuery warehouse and run some advanced SQL query to understand the data much better. So this is whole integrated process, and let's get started. Alright, now let's take a look at the ERD or Entity Relationship Diagram to get better understanding about the data. If we see, we have a table which is called borrowers. They are the users or the customers looking for to have the loan from the bank. We have borrower ID and we have some demographic information such as the age, gender, the education level, marital status, state or the city, credit score, and created at. Created at means when that data is indexed in a database. But as you can see, each of the borrower should come from one employment status. Why? Because it is very rare that bank gives a loan to a customer who doesn't have any employment or doesn't have any income source. So we have another table and the relationship is one to many. We have employment ID, we have borrower ID, definitely, this is a foreign key. We have employment type, employer name, employment length here, or how many years that user has been working in that company. We have annual income and we have monthly income. Also, each borrower should have the credit history. Because if you are using the bank, definitely you have some credit history, and all those history can impact on the business making decision for giving a loan to you or not. We have the credit history ID as a primary key. We have borrower ID, we have account type, which kind of account type the user has. We have account age as a month, how old is the account. We have credit limits. Definitely, if you have higher credit limits and you have less amount of money owed, means you are a good customer. We have balance owed, we have payment history score, we have number of the late payments, if the user has any payment. We have number of the derogatory marks, it means how many installments you didn't pay. And we have inquiry last 6 months. So the relationship is many to many with borrower. Why? Because a user might have more than one credit history, and also credit history might be more than one customer. Why? Because there are, for example, one account, and that account is for a couple, and both of them are using. So it means even the credit history might be for more than one person. Another table is loan application, and the relationship between the loan application and a borrower again is many to many, because every single user might have many applications, and every single application also might have many users. We have application ID, we have borrower ID, we have application date, when we just applied for that loan. We have purpose of the loan, why we are applying for that loan. This is very important for the bank. We have a request amount, or how much we applied for. We have application status, what is the current status for that application. We have loan term months, in how many months should I just pay off all the loan. And we have interest rate for that loan. Also, every single loan application might have many loans assigned to that. For example, loan ID, application ID, borrower ID, all of them are coming from the different tables. But we have loan amounts, we have loan term months, we have interest rate, origination date, loan status, default flag, and monthly payment. This table of the loans is the correct or the current status of the loan. So what is the difference between loan applications and loan? In loan application, this is where you apply for a loan. And this is just the basic information about the loan. For example, you apply for a loan for 20K and the interest rate is 4%. But the bank later made a decision to give you 30K and the interest rate but is higher. So it means the loan is what bank made a decision. And the loan application is just application. So it means all the loans are those applications that have been confirmed, so they might be either changed or not. This is all the tables that we have, and we are going to start the project based on those. All right, so for the data warehouse in our project, I made a decision to use Google BigQuery. Google BigQuery is one of the best data warehouses platform, and I would like to take advantage of Google BigQuery because one section of my project is ML TensorFlow, and TensorFlow is work on the Jupyter Colab in Google, so I prefer to have the consistent data platform. I had also some other options like Snowflake or other data warehouses, but I prefer for this project, I use the Google BigQuery. Before do anything in Google platform, I should create a project. So I go ahead and select a project. As you can see, there is no project here. So I go ahead and select new project. The name of the project, I'm going to say credit loan. This is the name of the project, and it can't be changed later during the project. For organization, it doesn't matter. I just leave it as it is, and hit the create button. And as you can see, the project is just created. Now, if I go to the select project, you see the credit loan is here. I can click on that, and now we are on a page for this project, and the project ID is credit loan. Okay, we build the project. Now it's time to go to the BigQuery. I can go to the menu here and go to the BigQuery. In the BigQuery, I have a bunch of options here, but I don't want to talk about all of them because this video is not just teaching the BigQuery, it's about implementing the project. So I close the windows, and here we have the data warehouse, and this data warehouse is the name of I created the project. It is credit loan. However, I have the spelling error, but that's fine. I forgot to put the T in the middle of the name, but that's fine. Okay, now I'm going to create the schema or the data set. In Snowflake, we have the data warehouse, schema, and table. In BigQuery, we have project as a data warehouse. We have dataset as the schema, and we have also table. All right, now I'm going to create a dataset. How can I create a dataset? Just go there and create a dataset. I'm going to call, for example, credit data. Let's say bank data. This is much better. Yeah, bank data. The data location, I should choose the nearest place to me. It is just Montreal. It's the nearest place to Toronto. And I just hit the create dataset. So this dataset, as the bank data, is created as a schema or as a dataset under the credit loan as a data warehouse. But still there is nothing inside the dataset. We should import our data. In a real-world scenario, it is very rare that you import the data manually because you need to connect the dataset to some data sources. that data sources might be come from even the Google, Amazon, or other platforms like the company CRM or other data sources. But it is very rare to connect to the raw data. But for the sake of the project, I don't have that access to those databases, so I prefer to import the data manually. How can I do that? I create a table. The table means just a table as we have in other databases. I go and create a table. First of all, I should say what is that table. I'm going to upload that data because those data is on my local machine. I'm going to just ingest all of them to the BigQuery. Then I should select the file, so I just browse it. And this is my data. I can just import one by one. For example, I go for borrowers. I just select that. The format is CSV. The project is the project that we just created here as the project. The dataset is the bank dataset, and the name of the table, I can say table borrowers. It's just the name of the table. And for schema, I say auto detect. In that case, the Google can understand the data type based on the data that I have in my file. And for the rest, I don't have anything specifically here. For clustering, I don't have too much data to cluster. I'm not going to partition. I am just go ahead and create the table. Now we should wait till the job is done and my table is there. As you can see, the table borrowers are there. Now we can take a look at the data. That you see, we have all the field name. The Google just realizes it automatically. Or even we can go for the preview to take a look at the data. For example, we have borrower ID, we have age, we have gender, education level, marital status, state, credit score, and created at or when that borrower is created in the initial database. These columns are exactly matched with the ERD that I just showed you. I'm going to do the same process for other tables, and later I will show you the final result for ingesting all the data. Alright, I just uploaded all the data. As you can see, we have 5 different tables. We have applications. Just take a look at the applications. We have all the information about the applications. We have the borrowers we just saw. For employment, we have all the columns for employment. And as you can see, all the columns. Also, we have the table history or the credit history. This is all the history about the credit, for example, the history score. And we have the loans, which is the most important table in our project. As you can see, we have all the information about the loans, and this is just a default flag as a target column. 1 means that loan is assigned to that users, and 0 means the loan was not delivered to the customer. So we have all the users, and let's go for the next step for the project. All right, now in Jupyter Notebook, I'm going to start working on building model on top of TensorFlow modeling. This machine learning is going to help the managers and the stakeholders to predict whether a customer is going to be at a low risk to receive a loan or high risk to not receive a loan. First of all, I should import the dependency and the libraries. I import Google Cloud BigQuery because this is pretty important. Why? Because our data is in BigQuery warehouses. And after that, just because I'm working on Google Colab, I need the authenticator to connect my Google Cloud to Google BigQuery. Then I'm going to load data from BigQuery. First of all, I create the authenticator, and that authenticator is gonna be based on my user profile in Google. Then I should set what is my project ID or the name of the warehouse. So this is scalable. After that, what is the dataset ID or the schema? This is bank data. And underneath, we have 5 different tables: applications, borrowers, employment, history, and loan. Then I should set the client. The client is working as a bridge between my Google Colab and the BigQuery. So I set the client to the BigQuery library, and after that I set the project ID on that. Then I should create the dataset reference. Now it's time to connect the schema or dataset to that client. And now we said to that client, okay, let's go to that data warehouse and that dataset and get ready to read the table. Now the client is ready. The next step is that we are ready to read the tables inside that dataset. I create 5 different sections for 5 different tables that we have. For applications, I set the reference dataset client to the application, and after that, I read the data and convert it to the data frame. I do the same for borrows, for employment, for history, and for the loan. Let me run the code to see each of them has how many rows and how many columns. If I scroll down, you can see all the data ingested. Application table has 500 rows and 8 columns. Borrow table has 400 rows and 8 columns. Employment table has 400 rows and 7 columns. History table has 1500 rows and 10 columns. And finally, loan table has only 291 rows and 10 columns. So it means we successfully ingested the data in a Google Colab with help of Authenticator. Now we are reading data in a BigQuery, and we are able to make our TensorFlow model on top of this data. Alright, in the next step, we are going to do some feature engineering. It makes sense, because in the real world, we cannot only rely on the data that we have. We should do some feature engineering to create some features that might help our project or the model to have better accuracy. So I'm going to create a new data frame which is called credit aggregation. This new data frame is on top of data frame history. So it means I'm going to get data frame history, and after that, for every single borrow ID, I'm going to have some aggregations. For example, I would like to know what is the total account for every single borrower ID. What is the average account age? What is the total credit limit? Total balance owed? Total late payment? Total derogatory marks or derogatory? Total inquiries? And percentage of poor history. What is the poor history? I say if the payment history score is equal the poor, just grab the mean or the average. So in that case, I have the percentage for every single history, which is poor. And then I reset all the indexes. When I have that aggregation, after that, I will be able to create a new column, which is called utilization ratio. The utilization ratio is that if I have the scorecard and if I have the score limit, how much of them I paid or how much of them I used. So it means just divide total balance owed by total credit limits. And if this is null, I just convert it to then 0. So if we would like to take a look at the credit limits, the table is something like that. You can see we have the borrower ID And for each of them, we have some numbers as a total account, average account per each month, total credit limits, total balance owed, and all the information. If I scroll all the way to the right, we see the utilization ratio. For example, for the borrower 1, the utilization ratio is 1. And also, it might be even more than 100%, but just because we clip the data, it means at the highest we have just 100%. Above that doesn't matter. Why this user has 1 or 100% as a utilization ratio? Because you see the credit limit is $2,500, but the total balance that borrower is owed is almost $20K. So definitely the utilization ratio is more than 100%. So it means we just converted the credit history to these kind of data. And after that, we can just join this data with other data. Let's move on to the next step. In the next step, I'm going to merge all the tables that we have. We have loan as just a table we just imported. Then I'm going to join this table with borrow, then with employment. After that, with the new table we just created as a credit aggregation, and finally with the application. All this join table, you see the left, right, all these things and the keys are coming from the ERD. And it means the data modeling is very important when we want to join some tables together. In the next step, I'm going to say, okay, we have the merged data frame, but I need to steal some features when I have all the columns together. For example, I would like to know what is the ratio for debt to income. The formula is easy, just divide the loan amount by annual income. After that, I would like to have one more feature, which is loan to income ratio. Again, I divide the loan amount and annual income, but in that case, I didn't divide this number by 12. For the first one, I divided by 12, but not for this one. The next one is monthly payment burden. I divide loan amount by loan term months, and after that I divide that division by monthly income. Then I'm going to band or bin the credit score. I say I'm going to use the cut function in pandas and say, okay, this is my credit score, but based on this score, which is in Canadian standard, I say if this is 0.58, it's very poor. If this is 67, that is fair. If this is 740, this is good. 800, very good. And more than 800 is exceptional. I just cut and bind the data. After that, I create another feature, which is called income per age, which is I divide the annual income by age. And I just replace the 0 for the null values. And the last feature I created was DROIC per account. I simply divide the total DROIC marks by total account. And again, if I have any null values, I convert it to 0. If you would like to take a look at the data frame, this is our final data frame that we are able to build our machine learning model by TensorFlow on top of that, and we have all the columns. In the next step, now it's time to pre-process the data. Before do any pre-processing, we should mention each of our features that we have is based on what kind of columns. First of all, I mention what is my target column, because every single machine learning model needs a target column. So my target column is default flag, which is 1 or 0. I also don't need some columns and I would like to drop them. For example, loan ID, application ID, borrow ID, loan status, origination date, and monthly payment. Now I would like to say which are my categorical columns and which are my numerical columns. Why this is important? Because for data transformation and one-hot encoding, it is very important that we should know which columns we are going to do which method for data preprocessing. Then I define, my X or my feature is all the columns that I have in data frame except the targets and all those columns that we don't need it as a drop columns. And Y or target is just only that specific column. In the next step, I say, now it's time to encode categorical column. I use the label encoding and I say for every single column that I mention in categorical column, just do label encoding. And then just apply that label encoding in my original feature columns. And after that, I append those labeled or one-hot encoded categorical to my features. I first impute missing values. For the missing values, I use the robust method, which is based on a median. And I impute this strategy on my feature columns for all the numerical columns if I had any missing values. The next step is train, validation, and test the suite. This stage is very important because in this stage, we should split our data into 3 different sections. Definitely, we need the train for training the model. We also need the validation test to evaluate how good model is working. Also, we need the test to apply that model on unseen data. So first of all, I just split the data into 3 different sections. Xtrain scaled, Xvalidation scaled, and Xtest scaled. And after that, I should make sure about the class imbalanced weight. When everything is ready, we just get the number of the features that we have. Let's see what is the number of the features for this project. We have 29 scaled features for our deep learning model. Next, I create a function which is called build model. This function is responsible for applying the deep learning model on my data. First of all, I create 3 units. These units, whenever in the model I would like, they can just apply as a block. For example, for unit 1, I say this unit has 128 neurons and 512 as a layer. For unit 2 and unit 3, the same. I also define the dropout to prevent any overfitting. I also mentioned the learning rate, and the learning rate is just some of these options. And for L2 regularization also is one of those options for overfitting. All of these options for hyperparameter tuning. For example, unit 1 can be one of options between 128 and 512 with a step of 64. Unit 2 between 64 to 256, and unit 3 between 32 and 128. Also for dropout, the choice is a float number between 0.2 to 0.5. Also, the learning rate is just one choice between these numbers, and also for L2 regularization. Then I define the layers. And definitely the shape is number of the features that we just saw, 29, and we call it as an input. Then I define my 3 layers. Layer 1, layer 2, and layer 3. All these layers, just because they are in the middle of my deep learning model, For activation function, I choose reload. And I'm not going to be worried about the zero or the Bayesian gradient descent because I'm applying L2 regularization. And then the final layer is just the out as a sigmoid. Why sigmoid? Because we are dealing with the classification model. So the output, it should be just one option, 0 or 1. Then I have all these layers. I go and select the cross model to append all these models and compile together. And the last function is binary cross entropy. Because as I said, the options is just 0 or 1. It is binary options. The metric, I say the accuracy. The AUC, also I'm going to have precision and recall. And finally, I'm going to return the model. I apply this function. Now it's time to apply all those parameters with hyperparameter tuning on our data to see which combination of metric is good for our model. So I choose Bayesian optimization. Bayesian is good in this case because Bayesian can guarantee that every single round is better than the previous round. So it reduces the number of the round, but it also guarantees we are improving. And then I'm going to just go for 8 trial. And the objective is just validation accuracy, and the direction is max because we are looking for have higher validation accuracy. I also set some callback early stopping because I would like to not have the overfitting. And my patience is 5. It means for 5 rounds, I can still wait to have the overfitting. If this is more than 5, definitely that overfitting is real and I'm gonna stop the process. Then I apply the search function to just trial and error for those combinations with epoch of 3. And after that, I'm going to find the best hyperparameter models and best hyperparameters arguments. If I run the code, we will have this function, and as you can see, we have all the parameters, all the information. Now that we have the best parameters, it's time to train the model, retrain the model on top of those parameters. And I just put some callbacks and apply the model fit on the X train and Y train with 100 epoch and batch size is 32. I also have some validation and the callback that I just set. And as you can see, I run the model and every single epoch is on the run. Let's go and see the result. You see, just because we have early stopping, in epoch 35, we stop. And this is the result in that epoch. The accuracy that we have for training is 94% and validation is 84. Also, precision for the training is 80% and precision for the validation is 57%. But just because our metric is accuracy, it's good to stop and the model is stopped. So now we have our best model for just applying this project based on the parameters that we just set. Now even we can go further and evaluate our model to see how we can evaluate the model on the test datasets. Because test dataset is unseen the data, and it is a good place to understand our model worked properly or not. I apply this function and see the result. And as you can see, the result is here. For tests results, the AUC is 99%, which is so amazing. And the accuracy is 93. If you remember, the accuracy for training was 94, and now accuracy for test is 93. And it means the model is working very good. Also, we have the classification report to see more details about the recall, precision, and F1 score. Now that we apply the model on test, we can just take a look at the data frame that the model created for us. To see if the model is good, we can push it to the BigQuery warehouse. Let's see. If I run it, you can see this is the result for prediction. If you take a look at the data, we see we have one column which is risk score, and in this case, we can see the low, medium, and high. Also, we have the recommendation, which is the model predicted. So that is amazing, and now we are ready to push this data to the BigQuery. Later in the BigQuery, if we want to do any visualization or any analysis on that, this data is coming from our machine learning or deep learning result, and this result is coming from the model prediction. Now I'm going to push this data to BigQuery. Okay, before pushing the data to the BigQuery, let's see what we have in BigQuery. If I go to the BigQuery, you see we have only these 5 datasets that we just imported initially. Now I'm going to import one table here, which is the predicted by model. So I go and say the final prediction, which is coming from this section, is going to go to Google BigQuery, the datasets, and then credit predicted. This is the name I'm going to call. Then I say the project ID, the chunk size is none, and if it exists, just replace. Let me run this code. Okay, we got an error. Let's see. Okay, perhaps instead of the dataset, I need to put name of the file set, and after that this. I guess it should work because I just append the name of the table on top of the dataset. Let me try. Yeah, now the data is going to be pushed in the BigQuery. Now it's done. Let's go to the BigQuery to see what happened. Just refresh it to see, do we have that table or not? Now, as you can see, we have one table, the credit predicted. This model is coming from the TensorFlow model prediction, and we can even automate all this process based on a scheduler. However, a scheduler needs some billing card, credit card assigned to Google Cloud. So for sake of this project, I'm not gonna apply that things, but as you can see, for every single loan ID, here we have what model suggested for us and categorized based on a risk class. So this is amazing. Later, even you can use this table for data visualization in Looker, Power BI, or even the Tableau. Now, ML section is done. For the next step, we are going to run some SQL queries to get better understanding about the data and help managers to make better decisions. Now they can apply this model and pass it to ML engineer to deploy it, to use it. Also, they have some data and they would like to have some insight, and SQL query in BigQuery can help us to give those insights to stakeholders. Alright, now it's time to run some SQL queries in Google BigQuery to get more information about the data. If I open the dataset, you can see we have 6 tables, but for exploratory data analysis with SQL, I like to use only 5 of them: application, borrows, employment, history, and loans. I'm going to run 2 SQL queries, and they are in advanced level. I'm going to do some funnel analysis and just ranking income segments. Let's start with income segments. I just opened the SQL query and let's start to write the query. The question is asking, identify which income segments carry the highest credit score. For answering this question, it's good to take a look at the ERD. As you can see, for answering that question, we need two tables. We need employment details and we need the loans. So these two tables are not in a direct relationship, but the common column they have is borrow ID. Both of them have borrow ID as a foreign key, so we can take advantage of these specific columns to join these two data. Also, we should make sure that we are going to use inner join because we are going to rank based on a segment. So it means the annual income can help us to just categorize the customers based on their income. So now let's jump back to the BigQuery and write the code. Okay, I'm going to first say select from. First, I'm going to work on a loan table. So table loans. And I'm going to call this table as L. And I'm going to join this table with employment. So I say join, which table employment. And I'm going to call this table as an E. And both of them, they are common for borrower ID, if I'm not mistaken. This is borrower ID. Both of them are using this specific column as just the common column for joining these two tables. Okay, which columns we need? We need the borrower ID, definitely. So borrower ID is coming from, why we have two, sorry, I should remove that one. Borrower ID is coming from the loan, so I say borrower ID. The next one is coming from the employment, so it's E dot annual income. The next one, I need the default flag, which shows that the specific users got the loan or not. So I say what is the default flag, and then I go for the last column. It's just the loan amount. So loan amount. These are the column. Okay, now let's run the code to see what we capture. Okay, these are all the borrowers. As you can see, we have borrower ID, annual income, default flag, and the loan amount that they just got. Okay, the next step, we should make some categories. We should create a column that shows what is the category for that specific income. So for doing that, I'm going to use the case function. So I say case, and I'm going to end it as, for example, income group. And inside the case, I have some conditions. For example, I say when something, then something else. I'm going to say when annual income is less than, for example, 30,000, then put as the category, for example, you can say low income. They are low income category. Then I'm going to just copy this one. And I say if this is, for example, less than 60,000, let's go for example, mid-income. Then if the annual income is less than 100, let's go for example, high income. And the last one, let's say it is greater or equal 100,000. Let's say lux income or the luxury income category. So these are my categories. And let's say, for example, 150, I guess 100, it's not very high category. And else, let's say else, it is just super light income. These are the category I categorized them. So let's see right now what we capture. If I run the query, we will have a new column, income group, and it shows based on the categories, based on annual income that we have. We have some just group categories. Okay. Now we are going to answer the whole question. We just have the first sections. We have income segments. That's fine. But how we can find based on a credit score? So in the next step, we should find the credit score for every single of these income group. How we can calculate the credit score, or how we can calculate the credit risk? I mean, the default flag shows how many percentage each of these income can make a loan. For example, what is the percentage for low income people to get a loan, or what is the percentage for luxury income people to get the loan? So we should put all this query inside the CTE. So I say with, for example, income segmented like that, as this is open parentheses, I put all of them and just close it. Now we should continue the code and let's go ahead and use this CT table. For example, I would like to say select from. Definitely we are going to select from this table, but what we are going to select? We are going to select the income group. This is the first column, definitely. The next column is that default flag, because this is the most important column for finding the percentage. And default flag is just 1 or 0. So it is if I just find the average for default flag, I'm calculating the percentage because this is 0 or 1. So this is the default flag and I'm going to multiply by 100%. I'm going to call it as, for example, default rate percentage. And just because I'm using the aggregation function, definitely here I should use the group by, and the group by is based on income. Let's see what we have. If I run it, now you can see the low income, we have 58%. Luxury income, we have 5%. High income, 12%, and mid income, 17%. Now I'm going to round the number because this number is so decimal. I'm going to round it just to decimal. That's fine. And also I need to put it as another aggregation function. So I say aggregated as, and I paste my code there. All right, now I have this table, but I would like to rank it. Rank based on a percentage. So I go and say select from this aggregated table. I need everything. Also, I need one more column, which is just a rank. Rank, I'm going to rank over all the tables because I'm not going to partition the data, but I should order by, and I'm going to order by the default percentage rate. This is ordered by default percentage rate, and definitely it should be descending. The highest percentage should be the rank one, and I call it as just rank. And now I have the data. Now let me run the query to see what we have. You can see right now we have rank number 1 is low income with 58%. Then we have mid income with just 17%, high income with 12%, and luxury income with 5%. It means this bank is fair because for those people, they don't have too much income. This bank gives them more loan. And also those people have the luxury income, they have a lot of money in their pocket. This bank is so strict to give them the loan. All right, this is the first query. Even we can go for visualization, and even we can work with different sections. For example, I'm going to use just bar chart. Dimension, I'm going to say group, and the axis, I'm going to go with just a default percentage. As you can see, for different sections, we have different percentage. This is the magic of BigQuery. However, Snowflake, also the Databricks, have this capability as well. Now let's move on to the next SQL query. We go to the funnel analysis. This question is saying track application funnel from submission to default outcome. It means in these specific questions, we are going to do some funnel analysis. It means we should have all the steps from when the users or the customers apply for a loan, and after that to see what is going on every single step for this funnel from A, that a user just applied, to end when user get the loan. We are going to see what's going on all these stages. So let's take a look at the ERD for answering this question. Okay, as you can see in ERD, we should work on 2 tables: the loan application and the loan. Because the loan application is showing all the steps, all the application status, all the steps, and the loan is going to tell us what's going on for every single status. As I said earlier in the beginning of this project, the loans column has the real data. The loan application is the data that it was supposed to. So we need some information from these two tables to answer this question. All right, now I go ahead and start writing a query. First of all, I say I'm going to select from the loan application because it is the table has all the steps. So I say table application and I'm going to call it loan application. Then I'm going to join with loan, but this time I should use left join because my most important column is table application and I would like to have all the columns from this table. So I say left join with table loan, and both of them definitely are using one column as an application ID. This is the column that both of them are using. Also for loan, I'm going to call it as L. Now, let's see what from each table I'm going to bring. First of all, I'm going to bring application status, which shows the steps, and it is coming from loan application table. After that, I'm going to again from this table bring requested amount. This is the amount that user requested when they want to loan. And after that, from the loan table, I'm going to bring the loan ID. And then I'm going to bring the loan amount. This is loan ID. All these columns. Let's take a look at the data to see what we have so far. Okay, we have just joined two tables, application status. These are all stages, all the steps for our funnel. Then we have requested amount. Then we have loan ID and we have loan amount. As you can see, just because we did the left join, for example, for row number 8, we have null values for loan ID. All right. Now, on top of this table, I'm going to have some information. For example, what is the total application for each application status? Or what is just number of the loan ID? Number of the loan ID means those are applications that converted to the loan. So I can just grab number of the converted to the loan. Then I can find the average requested and just average approved. So I'm going to make CTE for this table and then do some aggregation on top of that. So I go say with, for example, application funnel as I put all of them inside this one, and then I say select from. From is application funnel, and what I'm going to capture. First of all, I'm going to group data, group by application status, definitely. Now, what is my aggregation function? As I said, first of all, I need that column. Then I need to find the count of everything as total application. As, for example, total application for each stage, how many applications customers sent. The other aggregation function will say count loan ID as these are converted to loan. These are the applications that converted to the loan. And after that, I can go, for example, just the average requested amount, just copy average requested amount as average requested. Let me just round it. I just cut it. Round only 2 decimal. This one. And the next one is that just copy this one. And this time I'm going to just go for average of loan amount. And it is average loan. Okay, let's see what's the error. It should be comma. Okay. Now let's run the query to see what we have. All right, for example, here for approved step, we have 291 application and all of them converted to the loan. Average requested was 18,000, but the bank just based on an average just gave the loan around 7,000. For rejected, the total applicants is 110 and none of them converted to the loan. And average requested was almost 18K. For pending, we had 48 requested and none of them converted to the loan. And the average was almost again 18K. And for manual review, the bank staff manually reviewed 51 applications and they again didn't accept to give the loan to the customers, and the average requested was almost 21K. These are so interesting information for funnel analysis, and it's so helpful for the managers and stakeholders to think about it. Why, when they are working on a manual review or they are working on a pending status, none of them converted to the loan. For rejected makes sense because they are rejected. But for manual review and pending, none of them converted to the loan. That is so interesting information. All right, I hope you enjoyed this video. For this project, we just saw how a data warehouse like the BigQuery can help us to even apply machine learning model and use it to work with some SQL queries. Even we can go further and work on a Looker Studio in Google Cloud and convert all these queries at one chart or visualizations. However, that is out of scope of this project. Anyhow, I hope you enjoyed this video. If you would like to just download the material, just go to the description for this video and go to my GitHub to get that materials. Thank you so much, and I'll see you in the next video.